Similarly, if you look at the time-based generator circuit here, so role of the time-based generator is to provide the varying values of the sweep signals, right? The sweep is a modified form of the triangular wave where the retest time or flyback time is 0, right? So that you can synchronize the coming input signal on the channel 1 denoted by test terminal, right? So that signal can be synchronized with the help of the varying value of the time base. That means any of the input signal that you want to measure with the help of the CRO must be synchronized for the stationary pattern on the screen. Okay, the pattern may be sinusoidal, square, triangular, or recesses. Any type of pattern you can observe with the help of the CRO, but that must be synchronized, right? So we have to remember that any of the test signal must be in some multiple of the sawtooth wave or sweep signal. Otherwise, the signal will not be stable on the screen and you will not be able to observe the minute changes of the signal. So now, if you look at the trigger circuitry available in the CRO, so very big circuit is available. And what's the role of this very big circuit? Okay, Schmitt trigger is one part of the trigger circuitry, right? That is used to show the any other signal in terms of the square wave. Because if you look at the definition of the Schmitt trigger, so any of the irregular shape signals can be converted into the regular shape, and that's why Schmitt trigger is one part of the trigger circuitry in the CRO. But what is the means conversion now if you have a square wave, because the CRO is working on the AC signal, different signals here, and this square wave is of very big duration and a very big amount. So that's why there may be the multiple RC sections can be available in the trigger circuitry. So the square wave can be converted into the spike, right? Because the spike has a short duration and high amplitude, so that can trigger the circuitry and can show the time-based signal or the sawtooth wave signal or the sweep signal that is responsible for the synchronization at the CRT screen. So now, if you look at the power section here, so we are observing here so many types of voltages here. For example, one may be 24 volt, other may be 5 volt, one may be minus 12 volt, one may be 265 volt, right, or one may be 145 volt, right? So the question is that why so many types of voltages are required here? Because the different sections of the CRO, like the vertical amplifier, horizontal amplifier, Schmitt trigger, trigger circuitry, time-based generator, these require the different amounts of the voltages, and that's why the various power supplies are used here in the CRO. And if you look at another part in the power supply section here, so you are able to observe here the CRT unblanking circuit, right? So we have a blanking circuit as well as an unblanking circuit. The role of the unblanking circuit is to unblank the grid when you want to observe the signal during the test time of the sawtooth wave, right? So during the untest time, during the retest time, during the blanking time, what happened? The electron will move from the right to the left direction, right? So that may return into the secondary emission. That may return into the electron bombarding, right? So to avoid that period, what we need to do, that the grid must be blank during that time, right? And during the rest time again, when the electron is moving from left to right, so grid must be unblanked. So that's why we have the unblanking circuit is available here, right? So now let's look at the grid here. Okay, you are able to observe here the shield here, right? So this shield is for the protection of the electromagnetic interference, right? That will disturb the operation of the CRO and will change the value of the observable voltages. So shield is here to protect the CRO from the electromagnetic interference, right? If you look at the shield, right, the portion which is covered by the shield. So the lower part of this one is CRT. That is the main part of the CRO, because without the CRT we are unable to display the signal. right? So this batch plate is used to provide a various range of the voltages to the CRT. Okay, at the back portion, at the tail of the CRT, we have the cathode is available, right? So cathode is the deposited strontium and a barium oxide. That is connected at the tail portion of the CRT here. Inside this shield, electromagnetic shield, right? So okay, so that is the given part of the CRT, and that we have already seen in case of our theory class. So I think there must be no doubt about this part, that what is available inside the CRT. But still, I have to disclose those other things again. They inside the CRT, okay, you have the electron gun assembly, definitely the cathode, and which is indirectly the cathode is available, right? As well as we have the grid, okay, with a 0.25 mm aperture, the hole to make the narrow beam of the electron. So that is available in this whole section, right? Okay, so after the cathode and the cathode grid, we have the vertical side of the plates, horizontal side of the plate. But before going to the vertical side of the plates and the horizontal side of the plate, we must have the controlling of the electron, and that's why we have the pre-oscillating anode as well as the focusing anode as well as the oscillating anodes are available, and that is covered only by this portion, means only 2 to 3 inch section of the CRT only. So this whole section of the electron gun assembly as well as vertical reflecting plate, horizontal reflecting plate, as well as pre-oscillating anode, focusing anode, and oscillating anode are only available in the CRT, is the tail part of the CRT, and that section is only the size of the 2 to 3 inch only. So okay, look at the old electron gun assembly section here, which is used with the vertical and the horizontal plates, right? So here you have a set of the vertical plates. Okay, this broken part is available here. Still, we have the set of the plate, right? Like this one. So everybody is able to watch this. What were the components of the 20 years or 30 years back CROs, right? So here we can find that we have the vertical plates, and what were the shape of the vertical plates, or what was the size of those CRTs, electron gun assemblies along with the vertical and the horizontal plates, right? So if you look at this part, so what is available here? Here you have a power supply section, right, which is used to provide the different supplies inside of the CRT. Then you have a circular plate is given here. So this circular plate, right, where is the circular plate here? This is the circular plate here, and having certain drills inside this circular plate for making the different electron beams, right? Okay, here the section where I am indicating, this is indirectly heated cathode, right, capped at 6.3 volt. And what is the role of indirectly heated cathode? That a cathode is deposited with the strontium and the barium oxide. Okay, so that must be protected from the high temperature, and that's why this is a indirectly heated cathode. Okay, then you have a cylinder, right? So that cylinder was used for the focusing purpose earlier, as well as for the so these were the parts of the old CRTs, and so if you look at this part, right? So we have focusing anode here, right? So earlier in CROs, those were used 20 years before. So there were such type of electron gun assembly, and pre-oscillating anode, focusing anode, and oscillating anodes were same, right? So now we must have certain structures, right? And if you look at this one, so you can clearly observe that we have the side of the plates. Right, we have the side of the plate. So one is the horizontal side of the plate to move the electron from left to the right. We have the another side of the plate to move the electron in top and the bottom direction. So these sections were seen in the old CRTs, right? Old electron gun assembly as well as vertical and horizontal reflecting plates. So now let us look at the presently available set of the electron gun assembly and the different plates in CROs. So we have the another type of the electron gun assembly is available here. So we can find here that yes, this is a cathode, right? So cathode has strontium and a barium oxide for production of the electrons, right? Along with this cathode, we have a nickel cylinder, so which has a 0.25 mm of the drill at the center, so that the narrow beam of the electron can be created, right? The question is that if the electron passes through the nickel cylinder, so that must have a small velocity, right? So to provide a high acceleration, to provide a sufficient velocity, so that the CRT screen can be covered both in vertical direction as well as in horizontal direction. So that's why we always need a pre-oscillating anode. So here we have
but you are able to watch the shorted section of this pre-aspirating anode with another section. And what is the use of the shorted section? The pre-aspirating anode and the oscillating anode are kept at the same potential, means at a 1500 volt. So that's why, because of the same potential at the same voltage, they must be shorted so that a single connection can be done with the pre-aspirating anode and with the oscillating anode. So center part of this one is again a hollow cylinder, right? You are able to watch here the hollow cylinder here, right? So this cylinder is nothing. This is the focusing anode, right? So why this focusing anode is situated at the center? Because the focusing anode is used to focus the emerging electron from the control grid. Right, because when the electron passes through the control grid, so its motion is not linear, its motion is not controlled, right? So that's why focusing anode is used here. That is the cylinder here, which is capped at 500 volt, and the role of this focusing anode. Okay, this is the double concave lens is formed here, and that's why, because of the different potentials on both sides of the focusing anode, because one side of the focusing anode is connected to the pre-aspirating anode, that is at 1500 volt. Voltage of the focusing anode is 500 volt. So one lens is formed in between these two. Another lens is formed between the second part of the focusing anode and the oscillating anode, right? So two lenses are formed here, and these two lenses follow the law, Snell's law for the explanation, right? That how the movement of the electron can be controlled.